So in the context of manufacturing, let's have a quick look, and so that we get the kind of a base or the foundation from where lean really originated. So if you go back a few years ago, a few decades ago, really about 60s and 70s, the way manufacturing was structured was pretty much linear, pretty sequential. So you've got a product definition, the engineering comes in, they come up with the specifications and the mechanical aspect of it, then the electricals, then the manufacturing, then the industrial engineering, then finally the production comes and then they deliver. Is it ringing any bells? So it's pretty much like what we had in the waterfall. I'll show you that in the next slide. It's pretty linear, very sequential. You can't go back unless you put in a lot of effort. And then what we have now in the last 2 or 3 decades, thanks to lean, is basically a kind of a structure where a product could be developed, a new product. That's what we call in manufacturing as NPD, new product development. So new product development, whether it is pharma, whether it's car manufacturing, or whether it is some new chips in the semiconductors, whatever it could be. End of the day, the way that you try and produce and create a new product within any of these industries, it has gone through a significant transformation, a shift in the paradigm shift at that, in terms of how they approach it. So you've actually got these inputs and insights coming into the design from various stakeholders, and then they collaborate, they work together. It's not that they actually work in sequence, in parallel, in sequential order, but they're actually working in tandem and then trying to give the insights what matters most, and then they contribute to the product being created in a collaborative way. So there is no I'm important, you're not kind of a thing. Everybody contributes, even marketing, even at this early stage marketing, because of the customer focus groups and the insights coming in from the market, they input those into the product development. Similarly, the team leader, the mechanical engineer, electrical engineer, all of them actually contribute, and then the product takes a shape and then they launch the product. It's pretty much kind of resonates with what you have in the software development in the same context. So here with the waterfall, we've got till about the late 1990s, and even till about the mid 2000s, we had this context of waterfall model, right? So we've got requirements coming in, then your design, then development. We discussed this already in the agile overview and later as well. So I won't go into depth about this, but you understand the challenges, the problems, the kind of constraints that these kind of model, the waterfall models, offer to us. And then when you compare it with what you have got with agile, and it's a no-brainer because agile is really optimal, slim, it's lean, not much of hierarchy. It delivers things quicker. You get the feedback early. You fail faster than what you're doing with waterfall. And you've got involvement of people coming in very early on, right from the the business customers to the stakeholders to the users. They're all coming in early, so they are taking in as much of your product as possible. You're getting the feedback visibly quicker. All of these, so we had discussed this value of agile models and agile methodologies in the last few weeks, so you understand that. I don't have to reiterate again those. So significant shift in the way we work, in the way we think, and the way we deliver the software products as compared to waterfall about a couple of decades ago. Huge shift. And that's where, again, software development, thankfully, has actually taken some of these best practices from manufacturing, from psychology, from cognitive psychology, all these different aspects, and then it actually kind of embraced and took them into its fold. And that's where Kanban, your Lean, Six Sigma, all of these actually kind of came in from the manufacturing and the production setup. And then moving on, so you understand that in that context. So let's try and see how this really fares in the context of what we're trying to do today with the software development. So as I mentioned, Toyota, it started with Toyota in the late 80s, and then obviously Lean has started from there, and then it never looked back. And there has been a lot of adoption of Lean in pretty much most of the companies, not just manufacturing. Banks, in processes, in processing industry, in the engineering industry, in software development, there's a huge shift in the way we have been operating. A lot of principles and practices from Lean, like 5Y technique, the DMAIC, and the MUDA, which is about the waste, Japanese term for waste, all of these have actually started coming in from that perspective, which has significantly contributed to how we have been delivering the products in a significantly faster manner, but also in a much, much more qualitative manner. So there's a lot of reduction of defects compared to about 2 decades ago. So it all boils down to how we've been adopting, how we've been actually embracing some of these methods, the practices, and the principles. So just a quick look, we actually can relate to how each of the practices that we have now got into agile software development in Lean. So it actually kind of converges and then goes back to how it originated from Lean in the late 80s. So if you look at how for example, the context of Scrum or any Kanban kind of agile software development, you've got this kind of Lean software setup. So you've got people who are working in teams, which are with absolutely no roles. It's just a team. Everybody's a team member, no matter whether you're a programmer, whether you're a tester, architect, analyst, doesn't matter. Every one of us is a team member. And then we're working together to create that product increment, and that is potentially ready to be deployed into the production environment. So essentially what we're trying to do is to create an environment which is healthy, which is safe, and which is in order. And that's why you don't have a lot of desk space now in the offices. In the last, at least I've been working in the IT industry for over 20 years. I started in 2000. And in the last 20 years, there's so much change in the way even IT operated. Initially, it started off with, as I mentioned earlier as well, we don't have to have really big factory setups, not much of assembly lines. We just used to have just the desktops and a desk, maybe one or two drawers to actually put the stuff in, and then there's a desktop in front of us and perhaps a telephone. That was the setup about 10 years ago. And the same IT, if you look now, I guess, and maybe in the near future, as in the next few years, there's no desk, there's no, this whole hot desking now. So you can potentially, we're all working from home nowadays. There's no desk there as well. There's no desktop, there's no desk, there's all laptop, and perhaps even work can get done using the mobile phones and tablets. So it cannot be any leaner than what we're trying to operate on, right? So the overheads that you have on the business in terms of your IT setup is like really, really slim, very lean compared to, let's say, an engineering setup where you should have huge factories, and the factories have got equipment, inventory, raw materials, nothing in IT. So it's all down to how people had been trying to focus on lean and how they're trying to implement the lean within the IT setup as well. And then in the context of DevOps, for example, the latest trend, people had been actually trying to push things in the context of just-in-time production. So there's not much of waste there. People trying to create loads and loads of software. It's not there anymore. People trying to now write software just enough. And there's already some of the code, there's some code repository. So if you want to reuse some of the code that is written by your peer, by your team member, by all means, you can use it. So it's not about writing thousands of lines of code, which was about 2 decades ago. Now it's all about writing functions, writing calls, APIs, which are executing the same thing with maybe one, as I mentioned, example of Python, an SPSS software that I used I think roughly about 2099, 2000 was when I was working on a project where I used a software called SPSS, which is a statistical package. And now it's taken over by IBM about 4 years ago anyway. So that SPSS software is used to actually, it was primarily targeted for the statistical processes, statistical methods. So I used that and during my MBA days to work on a project to go through some of the marketing survey feedback and all the data, to analyze the data and write a regression model and create a cluster analysis model. So I created that, and because I was a student of statistics, I opted for that. So turned out I actually created a monster. I had to write no less than 20,000 lines of code just to come up with the basic analysis of this data. And I had to spend almost 3 months with SPSS to code using that. Now fast forward that to 2020. And in one of the premium banks just last year, I was working on one of the projects with a data science team. And we had to deploy and build, train, test, and deploy these models, statistical models. And now it's not called statistics anymore. It's called data science or AI, artificial intelligence, or it's called machine learning, whatever you call it as. But underlying is the same set of models, same set of regression models, same set of variance, ANOVA, same set of coefficients of variance, same set of time series. Everything is same. It's just that on the top, it just skinny, it's called AI or ML, just for the fashion. But what I did was the cut to the chase is basically we used Python and R to write the same set of 20,000 lines of code. We could achieve that by importing one library, that's one line. And then once you import it, call that API and then use the method, that's another line. 2 lines, just 2 lines of coding to replace the whole 20,000 lines of code worth functionality back in the 2000s. So imagine the kind of transformation that we've been going through. It's mind-boggling, thanks to all the lean and the Six Sigma, for example. And again, the quality, the kind of quality consciousness that has come through. Even a simple spelling mistake on the screens would actually put the people off. So there's utmost care, the way you structure your product, the way you put the design, the way it works, everything is more or less kind of standardized pretty much. Now the way the software development as a function or as a kind of industry has actually kind of achieved that maturity now. People expect your product to have minimal quality. And that's where we are trying to actually address some of the Six Sigma based quality. We'll talk more about it as we go through the slides. What is that and how it can be really used in that context. And then the teams have empowered. I mean, there's empowered teams are contributing so much to the quality of the software. You do not have to tell them what they need to do. So these are the people who professionals in the area, who are experts, subject matter experts. They would like to actually take the task themselves. They would like to self-assign the task to themselves, work on the task, and make sure that they would deliver. So that's the kind of approach that we're going to have nowadays. And the visual management is a very important principle, again, but coming back from all the way from lean about 40 years ago. But if you really look at it, visual management is what we're doing with software day in and day out with all those Kanban boards. I was showing the Kanban the last week. We're talking about the Kanban software. We looked at some of the Kanban boards, how the flow moves from one stage to another, how the work moves across the flow, how the to-do, doing, done, all those things, how we kind of use it kind of unconsciously now. But then back in the late 80s, it was so much of a stress and struggle. But again, thanks to lean, it's all sorted. And now it's all about, we all aim at perfection, but with agile, as they say, good is the enemy of perfect. So just do things if it is it's working all right, just deliver that and then improve on that later. So just do it kind of a work, philosophy is what we all need to. You don't need to have that perfection, or as they say, perfection is a goal, but you know what, excellence is tolerated. So if you're excellent, that's fine, don't worry. If you don't, but you need to target or aim for perfection. You can never reach perfection that way. So this is basically kind of setting the context and giving you inroads into how that could really be used in the pretty much the way that we deliver, design, develop, and actually kind of deploy softwares across the entire spectrum of our software development lifecycle. So lean has come and changed the way we think, changed the way we approach work itself. And so lean is definitely in all the processes, whether it's process, product, whether you've got a small setup, 2-people team or a 30-member team, it still is a fantastic approach that you could try and adopt into your